Students, in this video, we want to return to volume and talk about the volume of composite solids. So when you hear this word composite, hopefully you see its root, compose. And so what we're going to be doing is creating shapes from shapes. And so perhaps it's more accurate to say we're going to create new solids from various solids. So like in this particular case, I'm hoping in my kind of rough drawings, you can see this top shape is a cylinder. And on the bottom, it's like we've glued a cone to it. So hopefully you can visualize that. And so the way to solve these is I like to just label mine A and B. And that helps me because what I'm going to have to do is solve for the volume of the cylinder, solve for the volume of the cone separately, and then add those two together. So really our first step then is to say, okay, I want the volume of A. Well, what is A? It is a cylinder. Next question, what is the formula for the volume of a cylinder? It is the area of the base times the height. So it's pi r squared h. So in this case, we have pi. We know the radius is 4 feet. We're going to square that and then multiply by the height, which is also 4 feet. So this means if we leave pi in our answer, we have 16 square feet times 4 feet, which is 64 pi cubic feet. So the volume of A is 64 pi cubic feet. Well, step number 2, and again, as in my previous videos, I'm perfectly fine with you leaving pi in the answer. Number 2, I'm looking for the volume of B. This is step 2. Well, what shape is B? It is a cone. And hopefully you recall that the volume of a cone is going to be 1/3 the volume of a cylinder. And so that's going to be 1/3 pi r squared h. I like to put it all over a fraction, so let's move that 3 down below. I'm going to start with my pi and leave it there. The radius is going to be the same. It's also going to be 4 feet. We're going to square that, and then the height in this one is 5 feet. So as we work through this math, 4 squared is 16. 16 times 5 is 80. So we're going to have 80 pi cubic feet, but don't forget the 3. The 3 is still underneath there. Now 80 is not divisible evenly by 3. And so this problem is it's not difficult, it just doesn't work out nice and neat and even. And so what we're going to do for now is leave 80 over 3, if I can say it correctly, pi cubic feet. Now, 64 pi cubic feet and 80 pi over 3 cubic feet don't exactly add up evenly together. We've got a couple of options. If we want to keep it in more of an exact answer, then we would need to create common denominators, add the two, and you could report it that way. For our purposes here, it might make more sense, though, to go ahead and let's get the pi out of the answer. And so we're going to multiply 64 times pi, and that's going to give us approximately 201.1 cubic feet. I'm going to divide 80 by 3 and then multiply that times pi and get approximately 83.8 cubic feet. So here we have two individual volumes, 201.1 for the cylinder, and the cone is 83.8 cubic feet. So if we want a total volume, we're just going to say this is total. We are going to add 201.1 to 83.8 and get a total volume of this composite solid as 284.8 cubic feet. And that would be your final answer. So if we were to look at this example and say, what is the volume? The total volume, the composite volume, is going to be 284.8 cubic feet. All right, with that said, these are not necessarily that difficult. They just take a little time. And so what I want you to do is to pause the video and calculate the volume of this composite solid. But I do want to show you something, and this question comes up a fair amount. What is this? What are they doing right here? What I would love for you to do is picture this cube as made out of wood, and then someone takes a drill and drills a hole straight through it so that you could literally see, you could shine light through this hole. And so we have a cubic solid here, if you will, I'm going to call it that, but then we have a hole in the middle. I want you to think through, what do we do with that cylinder, that hole that has been drilled out of the middle, if we want to calculate a total volume? I encourage you to pause the video and try to figure that out. All right, so hopefully you did that. Let's walk through it. Step number 1, pretty straightforward on this one. We want the volume of the cube, which we know we could say is side cubed, or we could say length times width times height, but we know in a cube they're all the same. And so in this case, we're going to have 12 cubed, and that is going to be 1,728 cubic millimeters. Now, that is the volume of the cube, but remember, we have this cylinder in the middle, this one right here. We have this cylinder where I said someone has taken a drill bit and just drilled through. And so you probably used a drill before. It's going to rip or cut that wood out so that you literally have a hole, and the only thing occupying that cylinder is air. So the next thing we have to do is calculate the volume of the cylinder. Volume of a cylinder is going to be pi r squared times h. And so we're going to have pi. The radius is 1 millimeter, and the height we know is 12 millimeters because it's a cube. And so I did not write the height down, but I did tell you that it was a cube. And so the volume of the cylinder is going to be, I love to forget that squared. I think I forgot it there because it really doesn't matter. 1 squared is 1. So we know the volume of the cylinder is 12 pi millimeters cubed. All right, 12 pi millimeters cubed. That is the volume of the cylinder. Now, we do not have pi in the volume of the cube, so we need to go ahead and factor this out. I said factor it out. What I meant was multiply that out. And so when I multiply 12 times pi, I'm going to get approximately 37.7 cubic millimeters. Now I have something to work with. My step number 3, I have to subtract. I'm going to start with the volume of the cube, but I have to subtract the volume of the cylinder to get the total volume. And that's going to give me the total composite volume. So the volume of the cube is 1728 cubic millimeters. I'm going to subtract the volume of the cylinder, 37.7 cubic millimeters, and my answer will be 1,690.3 cubic millimeters. That is the total composite volume. All right, let's look at one more problem. Pardon the zooming issue there, but we've got that worked out. Problem number 2, this is a cylinder. This is a cylinder here with a hemisphere on top. It may not look like that, but that's what it is. It is a cylinder on bottom with a hemisphere on top. I would encourage you to pause this video and try to calculate the composite volume, the total volume of this composite solid. All right, well, hopefully you did that. Let's start off with step number 1, and we're going to do the volume of the cylinder first. So the volume of the cylinder is pi r squared times h. And so we have pi. The radius is going to be 6 inches. You'll notice the diameter at the top. It says 12 inches, so the radius is going to be 6. I'm going to square the radius, multiply that by 13 inches is the height. So once I do the math, I square 6, I multiply it by 13. I'm going to have 468 pi cubic inches, and that is going to be approximately 1,470.3 cubic inches. And this is a number that I'm going to need in just a moment to calculate the total volume. Step number 2, I have a hemisphere. But as I've said in class, I encourage you to use the volume of a sphere. So that's going to be 4/3 pi r cubed. And so I like to put everything over 3. Just go ahead and separate that out. It helps me to visualize the math. I think it will you as well. The radius is 6, so I know that I'm going to cube that. So let's execute the math. 6 cubed is 216, I'm going to multiply that by 4 and get 864 pi divided by 3. 864 divided by 3 is 288, and that's going to be pi in cubic inches. And to be consistent, we need to go ahead and multiply pi out, and that's going to give me 904.8 cubic inches. And I don't know how much I've said this, but I would always encourage you to use the pi button on your calculator. Avoid using 3.14 whenever possible. For most of our applications, it's fine. It's just a lot easier to use the pi button. And I think the further you go in math and science, training yourself early to just use the pi button will actually save you a lot of time and improve your accuracy. All right, so if we want to do the total volume, which is what we are looking for, I'm going to have, so I can say volume of total equals the volume of the cylinder plus, oh, we got to be careful here. What is this? That's the volume of a sphere. And so we want to divide that by 2. So if we divide this by 2, for the hemisphere, it's 452.4, and that's the number we want to use. So we're going to do the volume of, I'm going to call it the hemisphere. And so what we want to do now is just substitute our numbers in, 1470.3 plus 452.4. So what is our total volume? That is going to be 1922.7 cubic inches. So these problems are not necessarily difficult if you've learned how to calculate the volume of, say, a cylinder, a sphere, a hemisphere, a cone. It's just a little more work. You can see they are multi-step problems, and so you have to think logically through them to keep everything in order. I highly encourage you to number your steps. It's logical, it flows. Hopefully you can see from my math that I have a very specific attack method, if you will, to calculate these. And so anyway, hope that helps, guys. If you have any questions, make sure you send them my way.